Now this will be the last part of the dynamical systems and Markov chains. Remember the first example that we have discussed about the television market share. I showed you that after 10 years, 20 years and 40 years, the probability or the market share of the viewer for channel 1 and channel 2 tends to stabilize. And the same case also happens for the migration of lion. So when you calculate the 4th year, the 5th and the 6th, you can observe that the probability of the lion at reserve 1, reserve 2 and reserve 3 are roughly the same. So this is the condition where the state vectors seem to stabilize after a period of time. So are all the Markov chains have this property? So we want to know whether all the predictions have these stabilization properties or not. It is not guaranteed that all the Markov chains will have this property because it depends on the characteristic of the transition matrix. Such stabilization only occurs if the transition matrix is a regular transition matrix, which means that all the entries are positive or the power of P has all positive entries. Now let's look at one of the example here. So the regular Markov chain's transition P is regular. This is our original P transition matrix. When you raise it to the power of 2 or maybe power of 3, power of 4, power of 5, you shouldn't have a 0 here. If there's a 0 or a non-positive value here, then the P is irregular and the Markov chain does not come to a stabilization. So for regular Markov chains where stabilization will occur, there's a unique probability vector Q such that when you multiply the transition matrix with Q, you'll get back Q as well. So for any initial probability vector x0, the sequence of state vectors x0, px0, p square x0, remember the powers of the transition matrix of Markov chains that we've learned in the previous lesson. So it's actually converged to Q vector. So Q is the steady state vector of the Markov chains, which means that the vector where the values are in the stabilized form. So using these initial equations, you can rearrange it and then you can factorize it out. So you have a I minus P multiplied with Q equals to 0. So let's use the two examples that we have discussed in the previous videos to find the stabilized vectors. So for the television market share, given the transition matrix and given the original market shares, we can find out what would be the market share after a certain period of time, or maybe after the market shares stabilize. So using these equations, I minus identity matrix minus P transition matrix multiplied with Q equals 0. So this is I minus P and this is the Q and this is a 0. So you have to reduce it into the row echelon form. In this case, I didn't show it out, but if I'm going to show it out, it will be quite straightforward. So this is the first row, this is the second row. I just need to add the first row to the second row to get rid of the second row. So the new one will be 0, 0, and 0. And I multiply the first row with 1 over 0.2, so this will be 1, and this will be 1 over half, and this will be 0. So based on this case, I know that the first one, x1 and x2, so the leading one is for the x1, so the x2 will be a free variable, so x2 will be q. No, let's use another, maybe just let it be q. No, let's assume x2 equals to s, and from the first equation you have x1 minus half over x2 equals to 0. So x1 is half over x2, half over s, and then you're going to put s2 and s1 into this q vector. Oh, sorry, it should be q1 and q2 because we use the q vector here. So it should be q1, q1, q2. Okay, So q1 will be half over s and q2 will be the s. And because this is a probability vector, we could utilize this property where the summation should be 1. So q1 plus q2 must be 1, where the q1 is 0.5, q2 is s. So when you sum it out, you get s equals to 2 over 3, and you substitute it back. So the steady state vector for the market share will be 1 over third and 2 over third. So in this case, you skip the steps in calculating, you keep calculating the market share for a particular year. Because if you do not use this method, do not use this I minus P multiplied with Q equals to 0, you don't know when to stop. You have to try and error. Maybe you try to calculate the market share at 10 years, 20th years, 30th years, and then you just realize that, oh, the 1 over 3 and 2 over 3 will be the stabilized market share. But using this method, I minus P multiplied with Q equals to 0, you can straight away get the stabilized market. And similar case for the Lion's locations. So this will be the I minus P matrix, and this is a q1, q2, q3, and 0. So you reduce it into the row echelon form, and this is corresponding to q1, q2, and q3. So we have two leading one here, so which means that the q3 will be the free variables, and then you rearrange them, and utilizing that probability vector, summation of all the vectors must be 1, and you find out the value of s, and this is the probability of the locations of the lion after stabilized. So which is exactly the same as the probability when you calculate the 6 months period of the lion.